In this video lesson, let's learn about the binomial theorem, which is used to expand binomials of the form x plus y raised to n. Okay? Use the binomial theorem to expand each binomial. That's what the question says. And I have a binomial which says x plus y raised to 4. Okay? Now, if I look at this particular pattern, right? This pattern shows me that the binomial expansion of x plus y raised to 0 is 1. X plus y raised to 1 is x plus y squared is x squared plus 2xy plus y squared, and so on, right? Where the coefficients of each of these terms come from Pascal's triangle. So if I can see that the coefficient of the x squared terms is 1, the coefficient of the xy term is 2, the coefficient of the y squared term is again 1, which comes from these values of Pascal's triangle. Okay. Now these values of Pascal's triangle are actually combinations, and the rule which shows us how to create the binomial expansion of a binomial of the form x plus y raised to n, or a product of a binomial of the form x plus y raised to n, comes from the binomial theorem, which uses these combinations. Okay, so once we see how this pattern shows us binomial expansions, let's learn about the binomial theorem using which we can expand any such binomial. The binomial theorem says that for any whole number n, x plus y raised to n equals nc0, so that's a combination nc0, times x raised to n times y raised to 0, plus nc1 times x raised to n minus 1 times y raised to 1, times nc2 x raised to n minus 2 times y raised to 2, and so on, all the way till ncn x raised to 0 times y raised to n. Okay. Now looking at this pattern, what's important to note is that there are a couple of, actually there are 3 points which are important, and that's something we should remember. The coefficients, okay, they start from nc0 and keep going up till ncn. So the value of r starts at 0 and goes all the way up till n. Okay, so that's what defines the coefficients. The coefficients are the numbers in Pascal's triangle, which are actually combinations starting at nc0 going all the way up to ncn. Okay, now each term, if the binomial is of the form x plus y, okay, where x and y are the two terms of the binomial, then each term of the expansion also has an x term and a y term. Okay, so each term of the expansion also has an x term and a y term. The exponent of the x term starts at n and it keeps going all the way till x raised to 0. So it's n for the first term, x raised to n minus 1 for the second term, and so on all the way until it reaches x raised to 0, right? And for each of these terms, the exponent of the y term increases. So it starts at y0, it's y raised to 1, and it keeps going on until it reaches y raised to n, right? So that's how we expand these. Also, what's important to remember is that for any term, so if I take the first term in this expansion and I see the x and y terms and add up the exponents, the sum of the exponents is always n. So I can take any one of these columns and the sum of the exponents will always be n. Right? The total number of terms in this expansion will be n plus 1. Okay? So that's the rule which shows me how to expand a binomial of the form x plus y raised to n. Very simple to do. We just need to follow these rules. So let's start with x plus y raised to 4, which is our problem. So I have x plus y raised to 4. So this means I'm going to have 5 terms, because I know that I'm going to have n plus 1 terms, and the value of n in this case is 4. The two variables are x and y. This is all we need to know, and we can use the binomial theorem to start expanding. So let's first write down the coefficients. I know that the coefficients will start at nc0, so that's 4c0, right? The next coefficient will be 4c1, the next coefficient will be 4c2, the next will be 4c3, and the next will be 4c4. Okay, so these are the coefficients for each of the 5 terms that we are going to have. Let's now write down the x terms. The first will be x raised to n this will be x, which is x raised to 5, right? Because, sorry, 4, because the value of x is 4, right? X cubed for this term, x squared here, x here, and x raised to 0 here. Okay, this is x raised to 1. It's the same as x, right? For y, we'll start with y raised to 0. This will become y raised to 3, y raised to 1, or just y, because it's increasing. Y squared, y raised to 3, and y raised to 4. Okay? And now finally, we can add up all of these terms. So this is the expansion of x plus y raised to 4 as per the binomial theorem. We can simplify this because I can find the values of each of these combinations, and I can also combine like terms after that. So what we have here is 4c0. I know that 4c0 is 4 factorial over 0 factorial times 4 minus 0 factorial. So that's 0 factorial times 4 minus 0 factorial, or 4 factorial, right? And all of this actually just cancels out to give me a 1, because 4 factorial over 4 factorial is 1, 0 factorial is also 1. So I don't need to write this term at all. All I have left is x raised to 4 times y raised to 0. Y raised to 0 is also 1. So the first term is just x raised to 4. Okay. Now, remember, actually I should specify that how I use this is that NCR always equals n factorial over r factorial times n minus r factorial. So this is a rule that we should also remember. Now this also means that if I have a value of r such that r equals n minus r, okay, then NC n minus r and NCR are always the same. So this means that 4c0 is the same as 4c4. Okay. So if this was 1, this is also 1. Okay. 4c1 is the same as 4c3. Okay. And 4c1 will come out to be 4 if I use this formula. And 4c3 will also therefore be 4. And 4c2 is separate. Okay. 4c2 is 4 factorial over 2 factorial times 2 factorial, which equals 4 times 3 times 2 over 2 times 2. Dividing out the 2's, that gives me 6. So this is 6. Okay. So using that, let's substitute those values. I have a 4 here. X cubed and y give me x cubed y plus 6x squared y squared plus 4 times x times y cubed plus 1 times x raised to 0, which is 1 times y raised to 4. So all I have left is y raised to 4. Okay, so this is the expansion for x plus y raised to 4. X plus y raised to 4, if expanded by binomial theorem, gives me this result. That's my answer.